All right, here's a video on how to use the OpenScope to do a voltage measurement. A lot of times we won't use it to do DC measurements, but I mean we can. And yeah, so this will show you how. So again, same circuit that we've been using for the last bit of the activity. And the idea is one of the pins on the OpenScope, which is the 1+ pin. Let me switch over to the camera. It's the one that's orange. It is oscilloscope input 1, and it is just basically like a voltage input on the OpenScope. And so that's the thing that we want to hook up. And so when we think about what we're actually doing in terms of the circuit, what we're going to be doing is just plugging that voltage input into different nodes on the circuit. So kind of like when I'm in this measurement mode within LT-Spice and I plug my probe, at node B, and I say, oh yeah, that's 4 volts because I'm, measuring a 4 volt power supply, or maybe I connected at node A and I see that's like 2.64 volts, and I can't click on ground because that's by definition 0, and it just doesn't let me click there. Yeah, so basically we're just going to plug the pin from the OpenScope into those different places. So if we go back to the video, what that looks like is, I used an orange jumper cable for my +1 pin, so it's really easy to remember. Orange is my oscilloscope channel 1. So first, if I plug that into, this strip here, which is 5, and everything along that little row is connected together. So I just plugged in the oscilloscope into 5, and now let me go over to the instrument panel. So there's 2 things you have to do to get this to work. One is you'll want to set the trigger to off. And what that does is it's basically not going to look for either a rising or a falling signal to start collecting data. It's just going to kind of keep collecting data as fast as it can, and it'll display it. That's great for this application because we don't really have an oscillating signal or something, but there's a lot of times where we'd actually prefer to say always start collecting data on the rising edge, and so then our signals are going to line up in a nice consistent way, data set to data set. Anyway, that's the trigger thing. We're setting it to off, and then I hit run. It says no channels active, so I need to turn on channel 1. By default that should be on. Now let me hit run. All right, and there you have it. So what you see is actually 4 volts approximately. So if I kind of hover my cursor over there, it's telling me, something about 4.03, 4.018. There's a couple of tools that are handy here. There's math tools down there. They'll give you things like the average value. So the mean value of the voltage, 4.024. It's pretty consistent with what the power supply thinks it's set to, which is 4.013. And then there's also cursors that you can add to the screen. For instance, we can add voltage cursors, and they're basically things you can drag around and kind of get it to line up with maybe a particular part of your signal. And it's very, very small, but if you kind of stick your head really close to the screen, what you see is that cursor number 1 is set to 4.021 volts. So I basically, I made the cursor overlap the signal, and we get something very similar. If I was to, just pick a different point in the circuit to plug it into, so suppose I pick this other node, which is along kind of row 10 here. That should be at a lower voltage, and indeed the signal dropped down. I can put my cursor there and see that's cursor 2 is now at 2.67 volts. Yeah, and so it also gives us the voltage difference between those 2 cursors, which is 1.35, which should be the voltage drop across that first resistor. So yeah, that's how it works. You might be wondering, why did I only have to plug 1 wire into the circuit? And that's because when we look at the OpenScope, it's already got ground plugged in. And so it turns out that the ground for the DC power supply, the ground for the waveform generator, the ground for the oscilloscopes, all are in common. They're all shared, and so you just have to have one of them plugged in. And so if you have the one for the DC power supply plugged in, that's fine. If you plug in the one associated with the oscilloscope input, that's fine. If you plug in the one associated with the waveform generator, that's fine. And just one of them is sufficient. So that's why we get around just plugging this in one place at a time. All right, and that's as easy as it is.